Yeah, g'day, Mark here and welcome back to my channel. Now when you're surface grinding, you really want your grinding wheel to be balanced because any out of balance causes vibration and that transfers directly into your surface finish. So let's quickly build a wheel balancer. Now the key to making a wheel balancer is that you need an arbor. But luckily this one was made up for me by my mate Luke down in Malta. So now I needed something to put this on so that I can perform the balancing. Now balancing jigs are typically either like this with two parallel rails, or the arbor rotates in sort of pizza cutter wheels like this one. But James, Clo42, showed you can also get a pretty good balance if you just rotate it in ceramic skateboard bearings, mounted on a 3D printed stand. And then Werner of Werner's Whirligigs took that idea and simplified the design a bit, and also found some slightly less friction bearings to recommend. He uploaded it to the Thingiverse, so that's the one I used. Alright. This year, Christmas came early for me. So if you could just give me a hand, please.
Sure, we ordered something heavy again, did we?
I didn't order anything.
Me neither.
What is it?
Nobody knows.
Hey, speaking of Christmas, do you also end up with some pretty weird stuff on your Christmas trees? Sort of family heirloom sort of things? I mean, I'm really not too sure where they come from, but I'm pretty sure Christmas does not typically include a ballet dancing giraffe, an alligator with pom-poms, of course unless you're in Florida, one of those British Doctor Who telephone booths, or Darth Vader for that matter. But it's nice that Vienna's having its first nearly white Christmas in decades. We had a little snowfall today. Thanks for your help.
No worries.
That's got to be a joke, right? Who's got space to keep a cubic meter of box lying around? Chili plant overwintering in this room. Ta-da! Stickers, always good. Okay. Bambu gives you two different tubes to connect between the printer and the changer. One seems too long, one seems too short. I went for the longer of the two. I guess this is the rating plug which tells it what configuration it's in. We have something similar on jet engines. Tell them how much thrust they should generate. Here it probably tells the machine, am I an H2S? Or am I equipped with a cutter or a laser or something like that, I'm guessing. Now the X1 Carbon I had before was an amazing printer, so why the change to the H2S? When I was having issues with my bed adhesion and shrinkage on the housing for my DRO, for my surface grinder, I was talking to my contact at Bambu Lab and he suggested they upgrade me to the H2S, and it really gives me three improvements that matter. The first is with the increase to this build volume, when I get to the crankcase of my RedRip radial engine project, I should be able to print whole portions of the pattern in one piece rather than having to break it up and print it in three pieces as was going to be the plan with the X1 Carbon. The second improvement, which matters to me, is that the whole chamber has now a heater in it. So therefore to print ABS on big skinny parts like the DRO housing, what I should have been doing was turn the bed heater on, leave it to heat up for maybe an hour, and then start the print so that the chamber's already got some temperature in it. But the H2S now has a chamber heater, so you don't have to worry about that. And the third aspect which really helps me is that this comes with the new improved AMS2 Pro, which includes its own filament heating system inside it. Whereas before, I had to dry my filament in this independent dryer, which I bought off Amazon. Now, the filaments get dried directly in the material changer, and it's nicely sealed so that once they've been dried, they should stay dry for a while. So thank you, Bambu Lab, for upgrading me to the H2S. Now, just a disclaimer. I'm an affiliate program of Bambu Labs. They sent me this printer free of charge. They don't get to see the video. They haven't specifically asked me to make any specific sorts of video. They've just said use the printer in your normal workflow, which I do. There's an affiliate link below, so if anybody buys a printer or filament and uses my link, I get a small percentage of the profits. So I naturally have an interest in this stuff. Consider that when you consider my opinion. But the baseline is, I really like these things. After downloading the files from the Thingiverse, I just laid them out on the printer's build plate. And this build plate is so huge, it looks like I can fit everything in one print. That didn't work though, not because of the number of parts, but I kept getting retract errors every layer. Well, it's pretty good at telling you that it's an unhappy printer. So what's wrong here? Maybe I got the wrong length of tube at the back. They gave me both long and short tubes to connect, but I think the short one's too short. Maybe I'll put it over here, it'll work. Sure enough, that was the issue. Once I switched out to the shorter tube, I stopped getting those retract errors. I think that longer tube's used when you have to do external feed, like one of those very soft materials like TPU or some of the fiber reinforced materials as well. Well, these are my first prints. They're printed in black matte PLA, so it's the best possible material for hiding defects. There's not many. You can see a few warts along the side here. I did run a 12-hour drying cycle on this PLA before using it. It's a batch that's been open for quite a long time. At this stage, I only own the textured build plate, so one side of all of these have got quite a heavy texture on them. I do notice a wee bit of discoloration on a few locations. I'm not sure whether that's the PEI sticking to the plastic and coming off with it, but it's only visual, doesn't matter. For the balancing, you need something that's got as little rotational friction as possible. And these were the recommended ceramic bearings. They're 608s. Skateboard bearings, and this set of 4 only cost like $10. Considering how little mass they have, they seem to roll pretty well. Oops, one first. Okay, that shaft's probably a wee bit too loose. Let's see if I've got the screws that I need for it. Too long. Still too long. That looks about right. Now, I have both nylock nuts and non-nylock nuts. I think I'll use the non-nylock nuts because they're black. You could argue that I should probably use nylock here, but then again, who really cares? Now I printed these with very fine layer lines of only 0.12 of a millimeter. I increased the walls to, I think, 4 layers on the walls and top and bottom, and the infill to 40%, just to make it all feel a little more solid than just super lightweight. I really don't like the mix of textures between this one and the rest of these parts, but hey, with my next filament order, I'll just order a smooth build sheet and that'll be that dealt with. Right, let's just tweak this so it sits flat. What happens if you put the wheel on it? Right, so this is the light spot. Now, while everybody loves a wheel balancing video, I think what everyone's most interested in is what difference does a balanced wheel make in the actual grinding performance, in the surface finish. So let's do a few comparisons. Now this is the wheel I did some grinding with recently. So what I'm going to do is just quickly remount it, grind with it and see what the surface finish is like with this imbalance. Then we'll balance it, mount it again, see what difference that makes to that surface finish. Now I've also got a second grinding wheel here, which is pretty heavily worn down, but I've had some pretty nice results with it. I think it's just a basic aluminium oxide wheel. So let's have a look at its balance while we're at it. Okay, so that looks to be the top. Now this wheel is mounted to a hub which has no balance weights or anything like that. So to balance this one, I'll do the brutal method that Stefan Gotteswinter uses. Actually, I'll test 3 types of wheels. Now the pink one and the grey one were already mounted and have already been dressed, but the blue one I've just mounted. So let me mount this into the grinder and just dress it round before we start with it. Right, so we're going to do side 1 is blue, side 2 is grey, and side 3 is going to be pink. Right, in the deburring I've given it, you can see that I've had a go at trying to turn this metal flat on the lathe. So I don't know how flat it is, but that doesn't really matter for this usage. First surface, number 1, blue. Okay, so that's surface number 1 with the blue wheel. What we had was 1 heavy roughing pass, 1 cleanup pass at 2/100ths of a millimeter, 2 passes at 2 microns each, and then a spark out pass. Next up, side number 2 is going to be the grey wheel. Okay, so the grey wheel number 2, which is still readable, felt like it was bouncing around a lot, didn't like the initial roughing cuts, therefore it took a lot more passes to spark out. I'm pretty sure this is a finer wheel. I think this is a 60 grit aluminium oxide, whereas the other 2 are 46 grit wheels. Also, you can see quite a pattern in the surface there. Okay, so our pinky number 3 also cuts much cooler than the grey one, but once again you've got a bit of fish scale or whatever you want to call it in the surface. I'll also quickly redress each wheel before they go for balancing. Remember I said at the start that these 2 wheels had already been mounted and dressed beforehand, so I didn't redress them? Well, that was a mistake, because this one was definitely not dressed beforehand. That probably explains that terrible surface finish and the amount of bouncing, because when I dressed it afterwards, it was way out of round. So I would say that the surface finish on this number 2 is probably not representative, because it wasn't a dressed wheel running round. There's a wee bit of a pattern in it. And this was also a previously dressed wheel. Right, let's balance them. Actually, I'll turn it around so we can see better. So if that's our light spot, just need to move these up a little. These are kind of crunchy, so probably have to tap it around a little. Okay, needs to be moved more. All right, second adjustment. Same place. Now third adjustment. Needs more. All right, what's that? Fourth adjustment. Are you guys also starting to wonder, so what happens when you run out of adjustment? Fifth adjustment. Man, it likes that spot, doesn't it? Sixth adjustment. What's that? Seventh, maybe eighth adjustment. I think we're now probably also getting into the friction limits of the bearings. I think I'll call that good enough. Right, first one done. This one's also got balance weights, so I'll do this one next. That's quite a heavy imbalance. More. Second adjustment. Okay, still the same. Okay, I'm getting close, but I'm also running out of adjustment. I think I've now got to about the limits of the sensitivity of these bearings. Now, how do we balance a wheel if we've got no balance weights? If you watched last week's live stream with Stefan Gotteswinter, which not many of you did, so I actually re-edited that into a discussion and posted it last week. So I would recommend you watch it. Anyway, this is the way Stefan would go about balancing a wheel like this. So it looks like this is the light spot. So I'll brutalize the other side with a masonry drill. Okay, needs a little bit more weight taken off there, but it won't be much. All right, just rechecked it, still not quite in balance. Yeah, I'm probably still maybe a little bit light down there. How's it now look? A wee bit more. That'll do it. Now, one thing I didn't mention, all of this may not be the issue for the surface finish. It may just be damaged bearings on the spindle. When I got this machine, the bearings were kind of crunchy, so I disassembled it and lubed it. There's a video, I'll make a link, but it's not impossible that those bearings were already damaged. See how the numbers are much more stable here on the vertical axis. This number used to jump around at least 4 to 5 microns with unbalanced wheels. With a balanced wheel, pretty stable, maybe moving 1 micron or so. So that's a definite improvement. Right, well that was the first wheel, which is also I think the coarsest. Right, so there's that finish off the balanced blue wheel. It's not perfect, but I think it is better than it was. Let's move on to the little grey finer wheel. Right, now this one should see the biggest improvement because the wheel was not dressed on the first attempt. I did re-stamp it, maybe I didn't need to. While there's a visible surface finish in it, it certainly feels amazing. Right, what sort of surface finish did that leave? Also, not bad. I think in all cases there's a significant improvement. You don't get the same sort of interference effect that you got before. However, the surface finish in no case is perfect, and there may still be bearing problems in there. Well, I guess it'll come as no surprise to anybody who's ever done any grinding that balancing the wheels does make quite a big difference. I mean, none of these are coming out as a real complete mirror, but the surface finish is definitely pretty darn nice, and definitely better than it was without the balancing. And it's a big thanks to James, Cloud42, for showing that a plastic 3D printed frame with skateboard bearings can work. Big thanks to Werner for finding the even cheaper, even better bearings and making a simplified design. Thanks to my mate Luke for turning up and grinding the Arbor. And of course, thanks to Bambu Labs for providing the printer to make this work. Cool, that's another thing done. And with that, I'd like to say Merry Christmas to everybody who watches my videos. Merry Christmas especially to my Patreons and members who supported me throughout the year. It's been fantastic. Thanks for watching.